In this video, we're going to look at two more examples of equilibrium calculations. So in this question, hydrogen iodide, when placed in a sealed vessel at 700 Kelvin, decomposes to form hydrogen gas and iodine vapor. An equilibrium described by the following balanced equation is established. So to write the equilibrium constant for that reaction, and that's our expression for Kc. Square brackets again important, indicating concentration. Second part of the question then, calculate the equilibrium concentration of hydrogen gas when 5 moles of hydrogen iodide decompose in a 12-litre vessel. The Kc value is 0.0185. Okay, so if we try and fill in our table first, we've hydrogen iodide, we've hydrogen, and we've iodine. Okay, initially we have 5 moles of hydrogen iodide, we have no hydrogen, and we have no iodine. The change then that we will have, if we substitute in an unknown, so we'll have x, so plus x, and plus x. Here we're starting with 5 moles, and then we're going to be taking away 2x. So we're going to use those expressions that we have, we'll substitute them into the expression we have for Kc and try and figure out what our concentrations are. So if we come over here, alright, so Kc, right, concentration of hydrogen is x, same for iodine, and then for our hydrogen iodide it's 5 minus 2x, and that's squared. Okay, that 2 squared coming from there. And we know also that that is equal to 0.0185. If we rewrite this, on top we have x squared, and below the line we'd have 5 minus 2x squared. Right, we want to try and get rid of those squares if we can. If we find the square root of the left hand side and find the square root of the right hand side, we will do that. So that will then result in 5 over 5 minus 2x is equal to 0.136. Then it's just algebra. Okay, so we'll have x is equal to 0.136 divided by 5 minus 2x. That will result in 0.68 minus 0.272x, giving us 1.272x. That's equal to 0.68. So x is going to be 0.68 divided by 1.272, giving us a value of 0.5346. That is our value for x that we were looking for. Okay, so at equilibrium we're going to have 0.5346 moles, 0.5346, and here you're going to have 5 minus 2 multiplied by 0.5346. Now, they are not the calculations, or sorry, the concentrations, because in our question it says that it took place in a 12 litre vessel. So to get all those in moles per litre, you're going to have to put them all over 12. Okay, so that gives us a concentration for hydrogen iodide of 0.3279. Here for hydrogen 0.0445, and here again 0.0445. And we'll move on to our final example now. The thermal decomposition of phosphorus pentachloride is represented by the following equation. A mass of 20.85 grams of phosphorus pentachloride was heated at 523 Kelvin in a closed 8 litre vessel. When the reaction had come to equilibrium at that temperature, it was found that 80% of the pentachloride had dissociated. So we're going to focus on the calculation part, so that's going to be part 3 here. Okay, so we need to calculate Kc for this reaction. So first of all, we'll write our expression for Kc. So Kc is going to be equal to PCl3 Cl2 over the concentration of PCl5. So that's our expression for Kc. If we look at our chemicals that we have, so PCl5 and that, oops, sorry, is to PCl3 plus Cl2. Okay, we're going to try and do one of our tables. Now, in our question, it told us that we have 20.85 grams PCl5. Alright, our relative mass of PCl5 turns out to be 208.5 grams. So, moles is equal to mass over relative mass. So that's 20.85 over 208.5, so 0.1 moles PCl5 initially. We have no moles PCl3 and no chlorine at the start either. The change that we're going to have then, this is going to be minus x here. We're going to gain an x here and gain an x amount here. We are also told in our question, it was found that 80% of the pentachloride had dissociated at equilibrium. So that's 80% of 0.1 moles. So that is 0.08. 80% of 0.1 is 0.08. Here the same thing. So this is going to be 0.02 moles at equilibrium. This is going to be 0.08, and this is also going to be 0.08. Now, they're the number of moles we have, but they're not the concentrations that we are looking for. Okay, and if we don't have the concentrations, we can't find the value for Kc. So we are told in the question again that it happened in an 8 litre vessel. So all of those have to be divided by 8 in order to get moles per litre. So that is going to give you 0.0025 moles, 0.01 moles, and 0.01 moles. So that is the concentration of PCl5, PCl3, and Cl2. Right, we're going to sub those figures into the Kc expression we had earlier, which was this. Subbing those figures in, 0.01, okay, it's going to be 0.101 multiplied by 0.01, so that's 0.1 squared, over 0.0025, and that gives us a Kc value 0.04, and that is our final answer.